Hello guys, welcome to my channel Code with Priya. So today we are diving into a super duper concept, that is the implementation of linked list code in C++. I know as a beginner you might have struggled in the implementation of linked list code, though you are good at the concept of linked list. So what I mean to say is maybe you're conceptually good in linked list, but coming to the code, you might feel confused in syntax or logical building. So I'm sure this video will boost your confidence in creating and implementing the linked list. So today in this video, let's discuss the basic implementation of linked list in C++. So see, this is the basic skeleton of the C++, right? So as you know, the linked list consists of nodes, and the node consists of two parts. One is to store the actual data, and the another one is to point to the address of the next node. So let's create the node. As C++ does not provide any built-in nodes, we have to create our own node externally. So let's use the custom data type struct. So you can use class also here, struct node. As I said, node consists of two parts. The two parts are data and the pointer to the next element. Let's declare them. So the data and the pointer to the next node. Let's say our data is of integer type. It could be any type of your choice. And then what we have to declare? We have to declare the next pointer. Mm, yeah, we have declared. So our node creation is completed. Then what we have to do? We have to print the linked list, right? So our main aim in this program is to print the elements of a linked list. So in arrays, we will take for loop and print the elements. That means we will traverse the entire array and we will print the elements of the array, which is quite simple. But this is a complete different concept. We'll apply a complete different concept here. So see, so for printing the elements of a linked list, we'll take a function named print list. Here, the return type of the function is void. Why it is void means because it is not returning anything. It's just printing the element. It is not returning any element. That's why we are taking it as a void. So, what parameter the function takes means the function takes the starting node. That means from which node you want to print the linked list, that node is the starting point, and that starting point is the parameter of your of your function, which is printing of linked list. So let's write the function. So in this function, you have to place a while loop. Why means, see, you want to print the entire linked list starting from n, right? So that's why we are writing the condition n not equals to null. That means until the n is not null, till then we have to print the elements. So let's write that. What we have to do, we have to simply print its data and move to the next node. So let's write, simply we have to print the data of the node. Here we are assuming n is our starting node. So we have to print the data of our starting node, right? So let's print it by using the arrow operator, data. Yeah. Then we can, for our understanding purpose, we can just keep a symbol here just for our understanding purpose. It is completely optional as well. Hmm. Done. Next, what we have to do means we have printed the first node n, but we have to print the all other nodes also. So how we can do that? Then we can just write a condition for printing the other nodes, that is n is equals to n to the next pointer. So for example, if our list contains 3 nodes, so initially we taken first node as n. Here the first node not equals to null, that's why the node, the data of the node is gonna print here, and then the node will point to the next node. That means the first node will point to the corresponding second node. This process continues until the n becomes null. So at one point of time it will exit from the loop. It, what does it mean? It exited from loop means it reached to the last node. So the last node points to the null, right? See, if there are 3 nodes means the first node pointing to the second node, the second node pointing to the uh, third node, and since there are only 3 nodes, the third node cannot point to fourth node because in that list fourth node is not existing. Yeah, so we have written this. This is completely optional of your you can write, it is of your choice. Yeah, we have written this. And then now the most interesting part is our main function. What we have to do in our main function means, see, we have created a node class using the custom data type struct. Now in this node we have to label the nodes, right? We will do this in the main function. Let's say our node contains of some labels. That is, let's name our labels as head and initialize them with null pointer. Here we are just labeling the nodes. See, we cannot place the data here because it's just labeling and we are not allocating any system memory here. We will allocate the memory in the later part. So then let's name our node as head first and second. You can keep any names of your choice, that's completely user defined. So let's say second and initialize with null. Yeah, labeling is completed. Now what we have to do, we have to assign the system memory. How we can do it? Just take the label head, and for head we have to allocate system memory in this node. Wait, yeah, in this node we have to allocate memory for our label head. How we can do that means simply write the label name and then use the keyword new of a node. What this new keyword will do means this new keyword will allocate the system's heap memory, which is the dynamic memory. So similarly we will do to the other labels, that is first new node. I'll just copy this and paste this to the second label. So I'll take the second label and then paste it. Yeah. So we have allocated memories to head, first, second. After allocating memory, we can allocate the data. I mean, we can place the actual data. See, after allocating memory only, we can assign the data to it. Here we just label it. Here we cannot allocate the data. Now, what we should do here means we have to allocate the data. How we can do that? That's very simple. See, take label name and then take arrow operator, then take data. Let's say 10. And the important part is, as we discussed earlier, the first pointer should point to the address of the next node. So our first node is head and our second node is first. So our head should refer to the address of this first, right? So let's write here, that is head next is equals to first, and then we have to assign data to our first node. Similarly, we can do that. First data is, let's say, 20, and first next is, here what we should write, we should write second. Similarly, for second also we have to assign the data. Let's say the 30, and it will point to the null, since second is the last node. Yeah, we have we have written the all code. Now just we have to write a statement. This is completely optional. Just for user readability, I'm writing the linked list elements are. So we have created a function here, that is print list. So we have to just call this function, and I said the parameter is the starting node. That means from which node we want to print the list, that should be given as a parameter to this function print list. So let's do that. Let's call the function. So just let's give an handle here. So now we have to call the function, that is print list of, let's give our starting node as parameter, print list of head. So let's place an handle here for better readability. Yeah, that's all. Our our code is completed. So let's debug it so that we can find any mistakes in our code. So just debug it. Yeah, there are no errors. The linked list elements are 10, 20, 30, and null. So we have printed the elements of linked list. Simple program. Thanks for watching. Bye bye. Let's meet in the next video.